Alright, so section 13.7 talks about problem solving. And essentially what we have here are word problems. So the first step in doing a word problem is we have to read it, and the second thing we got to do is we got to read it again. Alright, so let's take a look. It says an object is dropped 36 feet below the tip of a pinnacle atop a 1,480 foot tall building. The height h of the object after t seconds is given by the equation h equals negative 16 t squared plus 1,444. How many seconds pass before the object reaches the ground? Okay, so I'm going to read that problem again. It says an object is dropped 36 feet below the tip of a pinnacle atop a 1,480 foot tall building. The height h. Okay, so this is telling me already right here, h stands for the height of an object after t seconds. Okay, so this is telling me something else. T stands for the time in seconds. And so the height of the the height of the object, excuse me, is given by this equation, h equals negative 16t squared plus 1,444. The question says, find how many seconds pass before the object reaches the ground. Okay, so right over here on the side, I'm going to say h is the height, t is the time in seconds, okay? So when I look at this part right here, find how many seconds, that tells you I'm looking for t before the object reaches the ground. Well, I want you to think about something. When the object is on the ground, the height of the object should be 0. So all I'm going to do is I'm going to take the equation h equals negative 16t squared plus 1,444, and where the h used to be, now I'm going to put the number 0. Negative 16t squared plus 1,444. Okay. Alright, so now I need to go ahead and solve this equation here. Alright, so the first thing I'm going to do is I'm going to see, can I factor anything out of both those terms? And so I'm going to take my calculator, and here we go. Okay, and the first number I see here is 16. I want to see if 16 goes into both those numbers. Okay, so I'm going to divide it by 16. Okay, it doesn't go in nice and neat, but you know what? I'm going to go ahead and factor out that 16 anyway. Okay, I want to show you what's going to happen. So if I take out a negative 16, now this is going to be a t squared. That's going to be minus, I already forgot what my number was, so 1,444 divided by 16, 90.25. Okay, minus 90.25. The reason I want to do this is I can use my difference of squares formula. If you remember, my difference of squares formula looks like this, right? Okay, and if you remember what we were doing with that number, we were basically taking the square root of that number. So I'm going to come back over here, I'm going to get my calculator, I'm going to take 90.25, and I'm going to take the square root of it. Oh, it's 9.5. Okay, so I'm going to go ahead and put that in, oops, right here, 9.5, 9.5. Okay, so now I'm going to take each of these parts and I'm going to set them equal to 0. I'm not going to use my number negative 16 anymore because I factored it out. And the only parts that are going to be equal to 0 are the parts that have the variable. These parts here have the variable. So I'm going to say t minus 9.5 equals 0 and t plus 9.5 equals 0. Okay. So when I add 9.5 to both sides here, I'm going to end up with t is equal to 9.5. When I subtract 9.5 over here on both sides, I'm going to end up with t is equal to a negative 9.5. Remember what t stands for? T stands for the time in seconds. So we have some sort of object, right? Here's a building. We're dropping that object down. We want to know how long it's going to take for it to hit the ground. Okay. Well, let's think about which one of these two numbers makes sense. Would it make sense that it's going to take 9.5 seconds for it to hit the ground? Or would it take negative 9.5 seconds to hit the ground? That doesn't make sense. We don't do negative time, right? So all that tells me is that this answer isn't any good, and the time that I'm looking here for is 9.5. Okay. I want to scroll down to the next problem because I want to show you it's going to be pretty similar to the one we just did. So now this one says an object is thrown upward from the top of an 80-foot building with an initial velocity of 64 feet per second. Again, let me go ahead and get my pen here. Look what it tells me. The height h of the object after t seconds is given by the quadratic equation h equals negative 16t squared plus 64t plus 80. When will the object hit the ground? This problem is very similar to the one we just did. So again, h stands for the height, t stands for the time in seconds. I'm going to write down my equation. H equals a negative 16t squared plus 64t plus 80. When the object hits the ground, that tells me that the height is now going to be 0. Okay. Just like we did before, I'm going to see if I can factor anything out of here. I'm going to try to factor out that negative 16 out of the entire problem, okay? So let's see. This should be a t squared. I'm going to get my calculator again. And let me see. How many times does 16 go into 64? 4 times, but because we're factoring a negative out, that's going to be a negative 4t. Okay. Let's do the same thing again. How many times does 16 go into 80? 5 times, okay, but because we're factoring a negative, that's now going to be a negative 5. Just like we did before, I'm not going to worry about this piece anymore. I'm going to worry about how do I factor this part. Okay? So I want you to notice the number here now is a 1. I can use my shortcut. So 1 times negative 5 is negative 5. The only numbers that I know to multiply to 5 are 1 and 5. Since this is a negative, that one, the bigger number needs to be negative, that one's going to be positive. Again, I'm just going to use my shortcut here, right? So this is going to be t plus 1, t minus 5. So when I set each part equal to 0, I'm going to go minus 1 and minus 1. So t equals negative 1. I'm going to go plus 5 and plus 5. So t equals a positive 5. Again, just like we said a little while ago, the time cannot be negative. I don't want to use that answer. This is the only one that I'm looking for. How long does it take for the object to hit the ground? It takes 5 seconds, right? Great. All right, so the next problem I have here is a geometry problem, and it says the length of the base of a triangle is twice the height. If the area of the triangle is 100 square kilometers, find the height. Okay, so let's take a look here. So here's the base. It tells me it's twice the height. There's the height, so it's going to be x, right? This is twice of that distance. And we're talking about the area of the triangle. So the first thing I want to do is I'm going to write down the formula for the area of the triangle. It's the base times the height divided by 2. Okay. So now I'm going to go ahead and write it here. The area is the base. Well, we're calling the base 2x. The height, we're calling the height x divided by 2. All right, what else do we know? Well, we already know that the area happens to be 100. So I'm going to write 100 in right here. I want you to notice that this 2 and that 2 will cancel out. And x times x is just going to give us x squared. All right, now I'll go ahead. I just need to solve this problem. So I'm going to go ahead and move my 100 over there. So that's going to give me an x squared and a negative 100 because we cross the equal sign. I can go ahead and use the difference of square formula. So that's going to be a minus 10 and a plus 10, because 10 times 10 is 100. And then we're just going to set each part equal to 0. X minus 10 equals 0. And x plus 10 is equal to 0. So when I add 10 to both sides over here, we're going to get x is equal to 10. And when we subtract 10 on both sides over here, we're going to get x is equal to negative 10. But let's think about what these things are standing for, right? What these variables stand for. X stands for the height. So the height here is going to be 10 kilometers, because we're in kilometers. Negative 10 wouldn't make any sense to say that, right? All right. So the last problem here out of 13.7 says find the dimensions of a rectangle whose width is 7 miles less than the length and whose area is 120 square miles. Okay, so first thing, why don't we just draw a little simple rectangle. Okay, and it says the width is 7 miles less than the length. So why don't we call x the length? The width would be x minus 7. It also tells me that the area is 120. Well, if you remember, the area of a rectangle is the length times the width. So I'm going to take x times x minus 7, and the area should give us 120. So let's go ahead and distribute that x. That's going to leave us with x squared minus 7x equals 120. I need to go ahead and move that 120 to the other side so that I can get 0 on the other side of the equation. Okay. And the number here is a 1, so I can use my shortcut. 1 times 120 is still 120. It's going to be negative because there's a negative right there. So I now need to start looking for pairs of numbers, okay? So let's think. Well, we can use 10 and 12. I don't think that'll necessarily work. What about 20 and 6? Nope, that's not going to work either. Let's see. 12 I can think of as 3 and 4. 10 I can think of as, say, 2 and 5. If we put 5 and 3 together, that's going to give me 15. If I put 2 and 4 together, that's going to give me 8. If I make that a negative, we can get our 7 from there. So again, if you notice, I'm just playing with my factors, and that's how I'm able to figure this out, right? All right, so let's go ahead and see what we can do here. I'm going to go ahead and write my 2 parentheses equals 0. So it's going to be an x with a minus 15 and an x with a positive 8. Okay. So again, I'm going to say x minus 15 equals 0 and x plus 8 equals 0. So from here, if I add 15 to both sides, I know I'm going to get x equals 15. This one I already know is going to give me a negative answer, x equals negative 8, which I don't want. Okay. All right, so now before I finish up, I want you to look at the problem. The problem says, let's find the dimensions of the rectangle. So we want to know both the length and the width. So right here on the side, remember what the length stood for. X stood for the length. And we came up with the length to be 15 miles, right? Because this is in miles. The width is 7 miles less. So 15 minus 7 is going to be 8. And there's 8 miles. So again, when we're doing these problems, it's real careful to make sure that we answer the question that's being asked.